Micro business owners lose valuable time to recurring, unstructured workflow friction. Small delays in supplier communication or missing information create an operational drag that drains focus and stalls progress. The wAI Scenario Lab is an Agents for Business prototype built to counter this exact friction. It aims to provide immediate, structured reflection without the overhead of a full consulting engagement. Before processing data, users must acknowledge explicit privacy and transparency notices, establishing a focus on safety. Instead of an open-ended chat, the system offers specific scenario modules. Each card targets a distinct operational bottleneck, like content creation stalls or recovery time after stressful interactions. This focus on strict scoping represents the project's foundational goal, helping microbusinesses through bounded reflection rather than high-risk autonomous execution. To see how this works in practice, we can trace the user path through a baseline example, such as the cool-down tax module. Once a scenario is selected, the system forcibly narrows the user's focus by presenting exactly 4 fixed questions. There are no unstructured text prompts here. The model only receives categorized, context-specific data, such as integer fields for tracking lost minutes. The system further protects the user by requesting only fictional or non-sensitive data, providing a primary layer of privacy at the input level. Forcing this deterministic 4-question funnel restricts the input surface area, creating a safeguard against unbounded requests or potential prompt injections before the agents even spin up. This is the final scenario brief, the document the pipeline generates once the structured inputs are processed. The system distills the raw input into a summary of the friction point and identifies exactly one low-risk, actionable next step. This reflects the core architectural mandate of the lab: one scenario, one insight, one measurement, one responsible next step. To maintain grounding, the brief recommends only non-financial measurements. This architecture is designed to provide a single, manageable starting point. The brief also explicitly lists the AI's assumptions and unknowns, highlighting the limits of its own analysis. This keeps the brief as an observational tool, ensuring the business owner remains entirely in the driver's seat regarding any execution. How does the backend ensure a generative model stays within these rigid boundaries without drifting? The solution is a 4-agent graph architecture built on the Google ADK SDK, which isolates specific responsibilities into distinct nodes. Tracing the execution path shows how tasks are separated. Splitting the logic across 4 agents prevents the instruction bloat that occurs in monolithic prompts. States like input and analysis are passed between nodes as fixed schemas. This means the analyst agent cannot alter the metric thresholds defined by the calculation agent. To ensure these transitions are reliable, the repository includes a deterministic local adapter for the graph. This adapter mirrors the multi-agent behavior, allowing the entire routing logic to be tested offline, even when live Gemini credentials are unavailable. By structurally decoupling agent roles, the system eliminates the hallucinated certainty that often arises when a single prompt handles both analysis and safety. Its scenario questions and metrics aren't hard-coded into the agent prompts. How does the system know what to ask for each different module? The project uses the Model Context Protocol to separate data from logic. This custom FastMCP Python server acts as a secure configuration gate. It dynamically loads scenario IDs and metadata from a JSON config file, keeping this content isolated from the agent instructions. The Value and Evidence agent queries this MCP server specifically to select observation measures, bypassing internal LLM generation for those metrics. Crucially, the MCP server scans for and prevents the leakage of financial terms, like opportunity cost, ensuring the output remains within the project's non-monetary scope. The MCP server serves as an immutable data boundary that generative agents cannot override. In a business context, AI tools carry the risk of generating high-risk professional advice, such as legal or tax counsel, that they are not qualified to provide. The wAI Scenario Lab refuses to entrust these mission-critical safety checks strictly to LLM prompting. Instead, deterministic regex and keyword interceptors run concurrently with the safety agent to catch personally identifiable information and high-risk domain requests. This screen shows the result of those checks. If a user requests an out-of-scope action, like send an email, the system triggers a hard stop. The deterministic router intercepts the blocked status, forcibly withholding the scenario brief from the front end. If the AI oversteps its confidence limits, the system forces a revision loop rather than issuing the brief. Layering deterministic code filters over the multi-agent graph provides a verifiable way to enforce safety compliance for business tools. To prove this architecture is robust, it must be supported by empirical evidence. The development followed a spec-driven approach, where expected outcomes were mapped directly to the scenarios using Gherkin feature specifications. This terminal output shows the results of the final automated test suite. These 97 tests verify every routing logic and safety intercept. They run locally using the deterministic adapter, requiring no cloud credentials to reproduce. These results provide empirical proof that the architecture behaves as specified, replacing the uncertainty of untested prompts with a reproducible software artifact. For micro-business owners, the true value of AI often comes when the system is designed to do less, acting as a grounded observer rather than an autonomous actor. This is achieved through 3 technical pillars: ADK multi-agent separation, MCP data decoupling, and deterministic safety routing. By maintaining hard boundaries, no account access, no automated actions, and no speculative ROI, the lab ensures the user remains the primary decision maker. The wAI Scenario Lab demonstrates that bounded, structurally constrained AI is the most effective way to empower small businesses while managing systemic risk.